Welcome to the webinar today. We present the data exchange between Catwork and RFEM today. My name is Gerlin Schubert. I am the moderator today. Hold on, slide should change over. Yeah. And the presenters today are Bastian Kuhn and Christian Levers on the Catwork side. So Christian Levers is our external speaker today. He's a sales engineer at Catwork. Catwork is a three-dimensional cut and CAM software for all fields of timber constructions. It offers a complete solutions from drafting to manufacturing. Christian will model a truss girder and a small timber building today. He will also prepare the models so that the export to RFEM and Erstab is easily possible. The company Catwork has offices in Hildesheim, Germany and in Montreal, Canada. The German offices support customers in Germany, Netherlands, Poland, Scandinavia and UK. And the office in Montreal supports customers in the US, Canada and also Australian. So when you have some questions regarding Catwork, you are welcome to contact Christian directly or write a support email. Bastian is responsible for the interface that is presented today in RFEM. He is also responsible for the RF Timber Pro and the RF Joints Timber modules that are used for the design today. So you will see in all these parts in the webinar today. Bastian will explain the features of the data exchange interface, and he will import the models prepared by Christian into RFEM, and he will design members, surfaces and joints. Christian and Bastian will work hand in hand today, so they will swap their screens and change their data. So I also want to introduce Amy Heilig down here, who is the CEO of our American office in Philadelphia. The office opened in summer 2015 and offers local support to our American and Canadian customers. Amy will answer your questions during today's webinar. This is just a little content. So I told you this already. This is basically what Bastian will tell you at the beginning. And here on the pictures, you see the two models that are presented today. So actually, you get two examples that are modeled in Catwork and that are imported into RFEM. Just a little word to the GoToWebinar screen. For the one who are visiting a webinar for the first time, you can show and hide the control panel with the orange button up here. And down here, that's the most important bit. You can type in your questions. So you can use the chat option down here. And we try to answer all your questions during the webinar. Please keep them as short as possible. And just in case there are too many questions coming in, don't worry. You will definitely get an answer via email as the latest tomorrow morning. So now I hand the screen and the word over to Bastian, and enjoy the webinar.
Thanks, Gerlin, for the introduction, and welcome everybody also from my side. As announced already from Gerlin, I will show the interface on the RFEM side today. I will lose a few words about the COM interface, which is an open interface that any software can use and which Catwork used to connect directly to our interface. I will show the behavior of the bidirectional exchange via the formats .stp, that is for beams, .sat, standard ACES text format, it is for surfaces, and .dxf for lines. I will show you how to design with the eccentricities or how to regard them when you get them over from the Catwork program, and I will show how to keep material and profile properties. So I will start and import something via the COM interface. I have here the program, our framework program Erstab. And I have three positions open there. There's a steel hull and a truss from wood and some columns. And so when you go to Catwork and go add files, You have here a button, erstab.com, that is only available if you have this additional license from us, and you can choose there, go erstab.com, and can choose which project you want to import. So for this webinar today, we will mainly show the behavior of timber structures. I want to import this wooden truss. Press OK, and Catwork takes connection to Erstab and imports it there. So here you can see that the properties of the profiles, the material properties are taken over, and you got all that information there. Next part is to import another truss that Christian Levers will model and show you how to model it in Catwork, and that's why I give the word to him right now.
Yeah, also from my side, warm welcome, and thanks to Gerland for the introduction, and to Bastian for the first impressions. So what we will do today is that first of all we will create a truss. And for this truss, I will use the new version Catwork 23, which will or is in delivering since a week, and we will deliver this to every client in the next weeks. So what we have here, or what I will use, is I will add this truss not by a single beam or a design, but I will just use a variant catalog file or a parametric catalog file. And this parametric catalog file is including now a straight truss. You see this one now is an inch. It just doesn't matter. You can switch between the values between millimeters, centimeter, meter, and you can edit inside here. So that means a parametric element. This is now a truss including all the parts of our beam. When I do a double click on it again, I'm back in the menu and I can change the values. For example, I change the truss width to 6 inch, the all over truss height to 5 feet, and so on. So I just use different values for my truss, and for the girder it should be 10, or let's choose a 10 inch and a 10 inch for the height of the top girder. The width of the side post should be a 4 inch, and so on. So that means I can just define the elements. I will choose a maximum field for the braces of 4 feet, and I don't, in this case for our calculation, I don't need this slotted plate, so I will put it to 0. Also the additional space, and also those parts here which will not be used. So that means with the change of the element of these values, I will be able to define an element like this, a truss like this. So you see it's a kind of parametric design. So now we also have some information about material and so on. So for example, this one now done is in glulam. There are some names inside and some values for the dimension. So you can define this all in the Catwork variant. But now, how to get this into RFEM for the calculation, we have several options. The first option is that I will activate all the beams, and I will go to Add Axis and define the system axis for each beam. That means now in the center, gravity center of each beam, there is now an axis, but you see what it's missing here is the eccentricities from this point to this point here. So at this first model, I will just define, or I will just change it by either moving the axis to the right position by using the shortcut command 5 for moving, or 7 for stretching, and I will define a new model which looks like this. So this is now just a quite simple way to define only the system axis, and we can just export those axes by export files, DXF file, into a 3D DXF file. I can choose the layer by color, material, or name or group. I will choose it by name, and this one should be called truss.dxf. So this is the first option to export a design or a structure from Catwork. So now I will just show another option which is possible, and this is a very, very clever one. This is available since version 23 for every Catwork user. Here in our design we do have a connecting surface. A connecting surface here from this part, and so from the braces and the top and bottom girder. So we do have a touching surface. We don't have to define anything on this touching surface, but what we can do is we can activate it, and we can go to Export Module and just select the point Structural System. So then we do have an internal analyzing tool, which is then getting an automatic connection between the braces and in this case the girder. So that means according to the touching surface, we have this eccentricity filled with a beam or with an additional element. Then we can save this DSTV file, call it trust.stp, and that means now we do have a step file which can be handled in the RFEM program, and Bastian will now show you how to do that.
Okay, thanks, Christian. I will actually split this presentation into two parts. What I'm going to do now is import this truss beam via DXF and via .stp format. And the design with these truss I will do with the Eurocode 5 with the annex from British Columbia, from United Kingdom with British Standard annex. And in the second part, where we're going to do a CLT position, which is a little bit more complex, I will do the design with our pretty new American design modules for some parts. Okay, so I will start with the DXF import. I have the possibility here to import also from some specific layer that makes especially sense when you have a bigger structure, to import, let's say, only, I don't know, only trusses and not the whole structure in one way. So I take this position truss, import it. I will choose the design standard, as I told, Eurocode 5 with British Standard as national annex, and make an automatic combination for it. So once I've imported it, I just make a plausibility check. So I have here the size 50 feet, so that is all correct. And as I'm in XZ area, I'm able to change my model to 2D XZ just to make modeling a little bit easier and not to have so many degrees I need to look for. Then I changed the top and the bottom girder into a profile. Let's say we could try something else with a rectangle 6 by 8 inch, and as a material I would choose favorite and all. I would choose some glue lamp, let's say pretty good material grade, let's say GL32 for top and bottom girder. And okay, and one more time, okay, and then I have that created, and I will also create a set of member to make an easier load input later on. Then this is now a continuous beam. It's not cut it in between the braces that I need to do as well. So now it's done here. And then I change the braces into a truss beam via the same way. And there I would use a profile rectangle, let's say 5.5 by 5.5 inch, and maybe not such a high grade material, only let's say GL28, just to have some difference, and make, as I said, a truss beam here, which is just nothing else than a beam with moment hinges on both ends. Okay, and then this truss is created. Now I need to define some support. So that's not movable in all directions, and here I would create a support movable in X direction. As a load, I would define subweight with characteristic value, and on top I would define some setup minus 0.5 kilopound per square feet, per feet, and one more time for the set of member. Okay, and a second load case for the snow, just to get some combination. You see now that I took the automatic combination with the Eurocode 5, I have already a classification of the loads, and I don't need to take care about this anymore. And as snow load, I would use minus 0.22 kilopound per feet. And so the loading is ready, and I would take a look for the combination. As an action, I would define ultimate limit state according to first order theory. I'm not taking care about serviceability right now, but it is also possible here. In the design process, I will just show the modules and not get too deep into the behavior of them. There are special webinars for each module what we are showing today. There's a webinar for Timber Pro, there's one for Laminate, and for joints as well. So that is that will be touched there much more detailed than I could do it now. Here we have design modules for timber beams for Eurocode and Switzerland with, I would say, nearly all national annexes I can estimate. American standard we have, Canadian standard, South Africa and Brazil we have as well. Okay, so in the first step I would do the beam design with Timber Pro. Choose there also the national annex from a British standard, ultimate limit state. As I said, I don't take care about serviceability and fire resistance. I will use a word about cross-sectional area reduction on the bigger module in the American standard design module later on. I could uncheck the stability design as lateral torsional buckling. I'm not interested right now, and also not buckling out of the narrow side. Calculate the truss and will receive a loading. So it's pretty low loaded with 40%. That's pretty low, but we must also consider the connections in between, which will narrow the profile one more time. And so to have a loading of 60–70% is pretty common for this kind of trusses. And now I would go to joints, but I forgot one thing. Joints is able to create stiffnesses himself or itself, and therefore I need to change that truss here, the beams one more time, from truss to beam, and make a hinge, a moment hinge on the end. So yes, you can see here that is now pretty similar here. On this point I'm going to define the connection, and we'll create the slip on by the module. One thing I forgot, I will go one step back just to show you the inner forces, because that is, I would say, pretty impressive for this structure. If you look for the structure right now, it is like we all learned in school. We have the moment on the where you have some kind of support here, the negative moment, and here on the end the moment is everywhere 0. And now when you change that with regarding some stiffness that is assigned here due to the connection, I would beam and moment hinge and go to the module joints. So the module joints is also splitted into 2 modules, or there are a whole bunch of modules inside. We are today only looking for timber, but it's also possible to design steel connections in there. You have also a lot of annexes. I would just design the if end with this cutting and use this node and this node. So it already recognized, okay, there's some connection possible, and I can take that here. The main member I want to have on top right now, that's what I'm changing. So I change that to main member and this to connected. Yes, yes. So then the connection is set. I just define some load to it and look for the geometry. I will not change too much here, just to have some more common thickness of the steel plate. And well, that I could change that to 0.55 and make pretty much doubles here, as I have a very high tension force here that I need to assign to it. 0.55, and then I put, what did I look for, 12 doubles in longitudinal direction on this side and also 12 on the other, and 0.55. Okay, that's a lot of doubles right now. In practice it is probably more common to use a user-defined distance here and to make there a bigger surface you can attach with the doubles. But as I said, for now, that should be enough. Now I can tell the module to export the stiffness to RFEM and make an design with an iterative design process by changing the stiffness outside and calculating the forces again inside. So you see, I got some connection problems here, some geometrical restrictions, but the loading of the doubles itself is not so high. That's all okay, but what it did during the calculation is just what I said. It made its own eccentricity, changed it here, and if you look for the inner forces right now, you see, okay, I have now also some negative moment here at the end where it was 0 before, and that's because of the more stiffness I assign with the doubles. Okay, that should be it, and now I'm importing the geometry from Christian via the .stp interface that already contains the eccentricity, so I don't need to take care about that there anymore. When you do the .stp import, you have an option here to use a conversion file for materials and cross sections. Very useful with any other program you are working, because you can combine the materials from the name from the other software to ours. Like every profile and material has a little bit different name in another software, just because a CAD program must look for other things than we must look in the static design. So right here I changed already a few things. What we could try out is just delete the glue lamp that Christian defined for the truss and then see that it's not working and then change it afterwards. So I save it. Go inside here and choose that truss from Christian. Yeah, I would not do the automatic combination right now. I think you've seen that all. And when I import it now, you see, okay, it's blue and the material is not found as I deleted it before. So we're going to do that one more time. Hold on. Just that I don't need to rewrite it again. I just copy it. Do not save it and say import. Took STB and choose, what did I say? I think GL28H, yeah, but according to British standard. Okay, save, okay. And now if I do it now, it should be imported with the material properties. And you see, okay, that's working now. The material is found. And now if you look for the model, you see it's also in 2D, so that's what I can change directly right now. Make it a 2D position and work with it in this area. One thing I need to say, this eccentricities here, the moment hinge should be downwards, it's upwards. Change it via right click and say member, reverse member orientation. And just to give you an estimation of the changes of the forces, of the inner forces, I load it, create also a set of member and a support similar to the one I just defined on the other structure. And on the right side I make it movable in X direction. Okay, okay, okay. And now I load it. Set of member, same load as before. And when you calculate it now, that's just what I wanted to show you, that you have then also negative, or it's not negative because the member orientation is changed, but you got a positive moment here now on the top, which is pretty similar to the one we just had. Okay, that will be the first part. Now Christian is going to show you how to model a more complex building, and I'm going to import it afterwards and design it according to American standard.
Bastian, do you want to show to import this one into Catwork again?
Yes. Yeah, thanks. I forgot that. Yeah, very good. Yeah, let's assume we need to change something. Yeah, I forgot it on Tuesday as well on the German webinar. Okay, very good. So let's say we change the, what do we change? We change the braces to maybe also a more common value, let's say 5 by 5. Say okay, and now that we need to increase the size, we export it to Catwork via this button. There's also a conversion column which makes the same way as I just told, and then I call it 1, 2, 3. Say okay, and then when I go inside Catwork, add files, DSTV, where was it? Webinar, Catwork today, 1, 2, 3. So, and if you look right now, you got the properties of the beam is assigned, and also the size of the profiles is changed, and also the material properties are imported to Catwork. So the big advantage of the...
Maybe one thing is go to modify, then we could see the material.
That's true.
So you see that now with this conversion table, we got the right material back into Catwork.
That's correct, yeah. And I did not change it to inch, so, but in Catwork.
No, that's not a problem,
Yeah.
it's just a thing in units. So it's everything okay.
Exactly, yeah. Okay, thanks. So I give the word to Christian.
Yeah. Okay, so from my side, now I will do a little bigger model that is now a complete house containing of 3 different parts. So the one is the roof, then we do have the CLT elements for walls and floors, and in this case a steel-shaped balcony. We will just define 3 different outputs here. So first of all, we will take a look at the roof. Also in the roof we have our beams, and we do have a hard and soft cut here with the purlins and the rafter. That means we do have a connection surface which is here horizontally and here vertically. So it means we have 2 connecting points. So this will be one point we have to look out later on if we define that. So for the support, we can either do this now later on in RFEM, but also we can do this already in Catwork. So as Bastian imported the DSTV file into Catwork, this was including also some nodes. And the node information is also including the support information. So that means in this case here, I will just use the catalog file I prepared. This is support, not movable in this case. And you see it looks like this. The only important thing is actually only the node on the top, this one. When I go to modify, you see that this is the normal node, but we do have the support information in user 8, 9, and 10. So this is just what is possible in Catwork, that you define the support settings for AirStab or RFEM directly in here. So that means this one here is just for visibility reasons. The important thing is the node. So we can move this, for example, in x-axis to that point with 6 for copy in x-axis. We can copy it to this point as well, or we can copy it either by 12 times in x-axis to that point. So it means that here we can easily define all the supports. Also, we can copy this one, all of them, by 6 for copy, S for symmetry in y-axis through the center of the ridge point, and we have on that side as well. So that means it's very easy to handle all the supports, and it will take you less work than later on in RFEM to define it. So it means now we will put it from here to here to have a support in the ridge beam as well. Copy it to the other side, to the midpoint of this ridge beam, and we do have all the supports we need. So by switching off the auxiliary elements, now we have a model which looks like this. So this is now including the rafter with, for example, material spruce, and the purlins and posts with the material glulam as well, like we had before. So when we now activate all the parts and go to Export, Module, Structural System, now the elements are defined, and the system just now finds that there are 2 touching surfaces in one point, so the horizontal and vertical one, and now we have to choose which one is our preferred. And we will now take the vertical connection as a preferred one, and then you see that we, on each touching point, we do have this additional element, the eccentricity here from the purlin to the rafter. So we will save this now as a roof, and it will be saved as a step file. So this was part 1. Part 2 will be the CLT parts, and problem on CLT parts is that we can't work like a beam on this one. We need an additional element for the laminated walls and the floors, and this is a middle surface we should work with. And to define this, we just created a small variant tool again, which is in Add, Variants, current folder in this case. We call this one Middle Surface CLT. So anybody who wants this file, just write a mail to info@catwork.de or to their connected Catwork reseller, and we will just send the variant file to everybody. So this is just a small variant when I define all the parts, which is then creating surfaces right in the middle of each element. Control A and M. So this, see, we do have now a rough module of these parts. So we can now go to cut and, for example, cut them to our surfaces, or we can just stretch, for example, all the surfaces to the right size. So stretch it in Z-axis to this point, for example. We can stretch the corner connections 7, stretch it to this point, and so on. So that makes it now quite easy again to find a model, nearly the same as working on the DXF model in this case, but it's in 3 dimensions and it's working with surfaces. So when we define it like this and we stretch those 2 parts as well in Z-axis to this point, we easily now get all the connections. So this one now can be defined or can be exported as a file, as an ASIS file or ASIS SAT file. We can choose, let's call this one CLT surfaces. We can choose a very high SAT file type. So in Catwork it's possible up to version 26. Here in this webinar we will use version 21 of the ACES file. Factor should be 1, and I will just save it. So now that means we saved all the information about the surfaces into one file. The third export would be the balcony, but in here we will not define the balcony for the with this automatic structural system, but we will just export the information about the profiles. In this case it's a steel profile, steel shape C5x9, and we will just export all those parts by using the export files DSTV file, just to show you the differences between this one and the structural export we did in the for the roof or for the truss. So I will just choose it, and I will just name this balcony. So that means now from this building with 3 different settings, so with the roof, the CLT and the balcony, we do have 3 different exports, and Bastian now will show us how to combine them into one single model to work further with this.
All right, thanks Christian. That's what I'm going to do. I will start by importing the roof and just design this roof on its own, because that's also possible right here. So I take this position roof, import it, and now I want to design according to American standard and also create the combinations automatically. And I go in here and have the structure ready. So you see I have the nodal supports and I have all the properties assigned to it, and I have also, if I change to the static system, the eccentricity from the purlin to the rafter assigned correctly, just to show you that it's possible to more or less directly start designing with it. I'm going to assign the self-weight before I put the whole model together. Here, whoops, just delete that little beams there. And now if you calculate it, there's not much load assigned right now, but you see, oh, hold on, that's probably my fault because I changed that little node there. Yeah, that's the one I just did not get correctly. So you see, okay, not much deflection, but it's possible to start designing with it. Now I want to import also the surfaces, the CLT panels, and that's I'm going to do via this additional module ACES, standard ACES text format. Import the model from Christian and also combine it automatically. So I have it here and I don't need to take care about the eccentricities anymore, as Christian did that for me. Then I can directly start defining the line supports underneath it. Possible to have a concrete floor underneath and design that in our concrete modules, but we just skip that out right now. Now in a timber construction, it's very important to have a moment-free connection on the edges. So right now it is connected stiff for moment, so that's not possible. That's I'm going to do via model data line hinges graphically. I'm just using the moment rotational release right now. We have another webinar one more time where the laminate module is explained much more detailed. There I'm going to take more detailed informations about how to calculate slip and so on and how to do that there. Right now this will be too much info. So I take this ones and the floor, and then I have the hinges assigned. Let's assume that it goes continuous from the bottom to the ridge right here, and I do the same here as well. One thing I just recognize right now, that it's not cutted. Here you see that this node is not integrated into this line. That I'm going to do via this command. And when I go on the line right now here, you see that this is working. Now when you combine one model to the other, or like put them in one model together, it's helpful to work with views there. That's what I also want to do. Just will help me defining load situations and so on. So the first view will be CLT. I have right here. Now I'm gonna import the balcony. It's also wire.stp, so that's balcony. Import it. I don't need the automatic combination there because I just put it to this model I just have. So I have that also imported. The importing right now is also with the conversion table for the columns, for the profiles. I just forgot it to show. And you see that we did not take care about the eccentricity here, but I can also do that easily in this module via member, extend member, and then put it to the next member, and now it's there. Connected, and I put also some support underneath it, and via Control C I put it to that other model. Say okay, and then I create also a view that I will call balcony, and so now I can just switch them on and off just as I need it. And the last step would be to import the roof to that. Before I do that, I'm going to delete the supports, oops, all supports, because I'm calculating with a 3D model. Nodal supports, delete, yes. And then also Control C, and tuck, tuck. And now I have that inside. It is now not directly integrated. One more time, I forgot to create a visibility roof. Most important for that. It's not connected right now. I need also to do that with connect lines on this position. So let's have a look if it all worked. That's a good hint if it's integrated into the ridge right here. That works, looks all good. The panels itself are now still some ordinary wood, but I want CLT panels from it. That's I'm going to do via the module laminate, and I will choose the American standard there, and I want to call the design according to load and resistance factor design. I forgot to design loads, so that's important for that. I need to do that, and I'm just putting load on top of the roof. That's why I'm switching off all the other views, and I'm creating a self-weight via generate loads via plane with, let's say minus, what did I write down? Minus 0.2 pound per square foot, and I connect, whoops, I will choose this node here and this one, and this one. Okay, so that load is assigned but in the wrong direction. So that makes more sense, yeah. Okay, the other side of the roof I will leave out right now, and I will create now the snow load on top. It's all so as I choose the combination before, it's assigned to the correct load duration class, and I can change it here as well and go tools, generate loads, snow load, do pitch roof, and American standard. I have also a mask here to choose the snow zone, the correct one I want to use, or I can choose it from some column I have. Now I choose the roof geometry. So this one, this And this, now you see it's not a really big model, but already here the views really make sense, because if I did not do it, I could easily took the wrong node from the CLT position, and that would just have screwed me up. That's why it really makes sense here. Say okay, and I leave the other wind load cases out. Say also okay, and now I have the snow load assigned. If I want to have a more detailed look, I can display that load separately and have a look how it's behaving. So now I go into the combination topic, go here, load combinations, and as I said, I wanted to calculate according to load resistance factor design. It's also possible to calculate with allowable strengths, but we leave that out right now. And I calculate once again also two first order theory. These are the combinations I will get out from these two load cases. Say okay, and now I can go one more time to the laminate module, choose the American standard, and say okay, I choose the combination for load and resistance factor design, so I use that, and choose also the combination to that and all surfaces. And material characteristics, it's possible to define all material properties your own and create a setup for the CLT panels, but we have also a wide range of producers, and we have also implemented the recommendation for the American market, or for America, with the recommendations from the Upper Wood Society. So this one, and for the walls we're going to make a pretty or more slim plate, because there is not much loading I will expect from that. Say okay, now I'm choosing the walls, therefore I will switch off the roof and maybe the balcony, does not really matter, and now just choose all surfaces, and the floor I want to have another setup. I can create a new composition right here, which will be a little bit bigger. Let's say this one. And now it's already assigned to the surfaces. They have now this property of the CLT panel. As I said, there is a special webinar where it's explained more detailed. It's probably not possible to create the CLT panels, I don't know, 8 meters long. You would in practice you would segment it into several pieces. I will not do that right here because we will run out of time in this case. Okay, and then I will calculate those panels and have a look what it did. So I got a little bit overloading, probably because of the snow. It's only, you know, on this little edges right here, so that's probably not a real problem. It's where I get the force from the rafters. That's probably something I could weigh out. And if I look for the, let's say, for the floor, that's a pretty good picture where you can see that I get bended loading on the panel, and here I get the negative bend load because of the wall that's underneath the panel. So that's all good. Now, as a last step, what I'm showing you, I will make the design according to the American standard for the roof. Because there's a new feature that was implemented by my colleague Gerhard Rehm, and I just want to show you how nice it works. I also choose this combination here, and because of that I will also use the same load and resistance factor design. In here I would disable the stability verifications. As in the American standard, torsional design is not regulated, and even on such a small position, because of the 3D design, you will get problems with small torsion, which is not really a problem, but it cannot be calculated. For that you can either have a ratio here or define a ratio. from what you want to disregard or what you want regard, or you can like completely ignore torsion. And what I'm talking about, what I was talking about, was the cross-sectional area reduction for the bird's mouth or for the notches that you have in the rafters here. Therefore, I choose the rafters on the end, the information about the orientation of the rafters. Okay, so and this. So I say I will make the notch on the member end, and the distance from the member end I will keep, yeah, just approximately ½ feet, and the depth of the notch I would take, yeah, let's say also ½ inch. And now when I calculate it, I have regarded that little notch. Okay, I still have got a small, or not a small, I got a big stability problem around this side. I probably took the wrong, yeah, you see, I just did it for one member. I need to do it for all members. That would be correct. So if I switch that off for all, I just will do it completely right here and have a look how the stress analysis of this is. Okay, I got still some problem on the dormer here. Okay, but we don't have time to look for that so detailed right now, but the design of it is more or less successful. There was a little problem I could not find out right now. Okay, so from my side, that's all, and I would give the word to Gerlind, or if Christian wanted to add something. I've seen there a lot of questions occurred, and Christian and Amy are working on that. So maybe I give the word to everybody else.
Okay, so from my side, very much thank you to be able to show that possibilities, and I think that maybe you get a good impression of what's possible to combine Catwork and RFEM or Airstab with the possibilities of this. So if there are any questions left, just call me or write a mail to your local Catwork office, and I think they will be able to answer that as well.
Many thanks also from my side. Many thanks to both of you, Bastian and Christian, for the very interesting presentation. Special thanks to Catwork in general for the good cooperation and all the preparation we had together for the webinar today. Many thanks also to Amy, who was busy answering all your questions. And Bastian mentioned 2 webinars during his presentation, and I want to show you this quickly on our website. So I go over to this is our new website, www.dlubal.com, and you find the webinars under news and events, and here you have the webinars. So it's a very long list by now. Here you find always the webinars that are upcoming soon. They're on top of the list. And when you're looking for some special webinars, the one that Bastian mentioned is, for example, the analyzing timber connections in RFEM and Airstab, or the analysis of cross-laminated timbers. Then instead of looking through the long list, it might be easier to have a look for the product RF laminates. And once you are on the product page, you get usually shortcut links on the left-hand side, and here you find the webinar, and then it already starts in YouTube. So this would be one way to find it. And there's another one. There's another one, I come back to this slide, the analysis of timber connections in RFEM and Airstab, this one, and the cross-laminated, and the third one, analyzing timber structures in Airstab might be also interesting to you. And I did show you the upcoming webinar already. This is data exchange between CMAR and RFEM, so this is upcoming soon. And for all American and Canadian customers, do not forget to request your PDH credit points. So you have earned professional development hours with this webinar. Please request your certificate. Just write an email to Amy Heilig and she's happy to send it over to you. So I show you the details again. This was on the previous slide. So for all German European customers, the top email is valid, and for the for the USA and Canada, the bottom email. And here you have the phone numbers as well. You can always have a look to the Dlubal website, as I did show you. So I thank you very much for your attention. Is there anything else we want to say, Bastian, Christian? No. Then.
No, thanks. Same from my side as well. So it was very nice to work together with you.
Well, thanks a lot. Okay, then see you soon. Many thanks for your attention. Bye.
Bye.